Before you fall asleep tonight, imagine stepping outside into a quiet field where the air is cool, the world is silent, and above you stretches an endless ocean of stars. There is something strangely comforting about the night sky. It does not rush. It does not demand. It simply exists, vast and patient, glowing softly in the dark like a cosmic lullaby. And yet, hidden within that peaceful shimmer lies one of the greatest mysteries humanity has ever faced. The universe is not just large. It is unimaginably vast, stretching so far beyond our understanding that even light, the fastest traveler in existence, cannot cross it completely. As you relax and let your breathing slow, consider this gentle thought. Everything you have ever known, every ocean, every mountain, every dream, exists on a tiny floating world drifting in a cosmic sea that may have no edge at all. For thousands of years, humans have looked up at the stars with the same quiet wonder. Ancient civilizations built monuments aligned with constellations, believing the sky held divine stories. Today, with powerful telescopes orbiting far above Earth's atmosphere, we have learned that those tiny dots of light are not just decorations. They are suns. Some are larger than our own star, the steady golden heart we call the sun. Some are dying in brilliant explosions. Some may host planets where alien oceans gently roll beneath unfamiliar moons. Yet the deeper we look into space, the more mysterious it becomes. One of the softest and most puzzling questions is this: where does space end? Imagine traveling outward forever, passing stars, galaxies, clusters of galaxies, and then more beyond that. Would you eventually reach a wall? A boundary? Or would the universe simply continue endlessly in every direction? Modern science suggests something even more strange, that the universe may be expanding. Galaxies are slowly drifting apart, like glowing islands floating away from one another in a dark and silent sea. This expansion has been happening for billions of years, ever since a moment we call the Big Bang, when all space, time, matter, and energy emerged from an unimaginably hot and dense beginning. But here is the calming mystery. If the universe is expanding, what is it expanding into? The question feels simple, almost childlike. And yet, even the greatest physicists do not have a complete answer. Space itself may be stretching, carrying galaxies along with it. There may not be an outside at all. It may be that the universe is not expanding into anything, but rather expanding as everything. It is a concept that gently bends the mind, not in a harsh way, but like a slow unfolding of a dream you cannot quite fully remember. As you continue listening, imagine drifting gently through space. There is no sound here, only the silent glow of distant stars. In this quiet vacuum, temperatures can drop to unimaginable cold. And yet, scattered throughout the darkness are nurseries of light, nebulae where new stars are born. These vast clouds of gas and dust slowly collapse under gravity, forming glowing spheres that ignite and begin shining for billions of years. The life cycle of a star is slow and patient, much like the universe itself. Some stars live peacefully. Others end in dramatic supernova explosions, scattering the elements that will one day become planets, oceans, and perhaps even life. Here is a soothing thought. The atoms in your body were once inside a star. Long before Earth formed, long before the sun warmed this planet, ancient stars lived and died, forging heavier elements in their cores. When they exploded, they spread those elements across space. Over time, gravity gathered them again, forming new stars and planets. Eventually, on a small blue world orbiting a quiet star in a spiral galaxy, those elements arranged themselves into living beings capable of looking back up at the sky and wondering about their origin. The universe, in this way, is not separate from you. You are a small but meaningful part of its story. And yet, despite everything we have discovered, we still know so little. Most of the universe appears to be made of something invisible. Scientists call it dark matter and dark energy. These mysterious components do not shine, do not reflect light, and cannot be directly seen. But they shape the cosmos on the largest scales. Galaxies rotate in ways that suggest unseen mass holds them together. The expansion of the universe is accelerating, as if pushed by a hidden force. Isn't it gentle and strange to think that most of reality is invisible? That what we see, stars, planets, glowing nebulae, is only a small fraction of what truly exists. It gives the night sky a deeper softness, a sense that the darkness itself is not empty, but full of secrets waiting patiently to be understood. As your thoughts begin to slow, imagine the Earth spinning quietly beneath the stars. Our planet moves around the sun orbits the center of our galaxy, and our galaxy drifts through an even larger cosmic web of structure. Everything is in motion, yet from our perspective, the night feels calm and still. That contrast is one of space's most beautiful mysteries. Beneath apparent stillness lies constant movement. Beneath darkness lies hidden light. Tonight, as you rest, remember that above you stretches a universe that is ancient, expanding, mysterious, and deeply connected to your own existence. You are made of stardust, drifting on a small world in a vast cosmic ocean. And somewhere out there, beyond the faintest star you can see, the universe continues its quiet unfolding, patient, infinite, and softly luminous in the endless night. Long before stars shimmered in the sky, before galaxies spun in graceful spirals, before planets formed and oceans gathered, there was a time when the universe was wrapped in darkness. Not the peaceful darkness of a quiet night, but a deep and ancient obscurity where light itself could not travel freely. If we gently drift back through time, beyond the birth of Earth, beyond the formation of our sun, beyond even the earliest galaxies, we arrive at a moment when everything was astonishingly hot, dense, and tightly packed together. This was the beginning of expansion, the event often called the Big Bang, though it was not an explosion in space, but the expansion of space itself. In those earliest fractions of a second, the universe was filled with energy so intense that particles constantly collided and transformed. It was a glowing sea of fundamental ingredients, swirling and shifting in unimaginable heat. There were no atoms yet, no stable structures, only a luminous fog of charged particles and light trapped together in a brilliant storm. Imagine a thick golden mist, radiating with energy, where light could not travel far before bumping into something else. The cosmos was bright, but it was not yet clear. As time passed, though time then moved in scales far beyond everyday understanding, the universe began to cool. Cooling in cosmic terms does not mean cold in the way we feel it. It simply means less energetic, less chaotic, more capable of forming structure. Gradually, tiny particles began to combine. Protons and electrons, once too energetic to remain bound together, started forming the first simple atoms, mostly hydrogen with a touch of helium. This gentle transition changed everything. When atoms formed, something magical happened. Light, which had been trapped for hundreds of thousands of years, suddenly found freedom. The fog cleared. Photons could travel long distances without constant interruption. The universe became transparent. This moment is sometimes called the cosmic dawn, not because stars had formed yet, but because light was finally able to move across the expanding cosmos. Even today, we can still detect that ancient light. It has traveled for nearly 13.8 billion years, stretching as the universe stretched, cooling as space expanded. What began as brilliant radiation is now a faint whisper of microwave energy filling all of space. It surrounds us quietly, passing through our planet, through our bodies, unnoticed and gentle. Scientists call it the cosmic microwave background, but you can imagine it as the soft afterglow of creation, a fossil light from the earliest time. Pause for a moment and consider that. The universe carries memory. It remembers its beginning. And with sensitive instruments placed in orbit above Earth, we have mapped this ancient light, revealing subtle variations, tiny temperature differences that are like fingerprints of the early cosmos. Those small fluctuations, barely noticeable, were seeds. They marked regions where matter was slightly denser than surrounding areas. Over millions of years, gravity slowly amplified those differences. Denser regions pulled in more matter. Clouds of hydrogen gathered, becoming thicker and heavier. And in the vast silence of space, the first stars ignited. These early stars were not like our sun. Many were massive, burning brightly and living briefly, pouring light into a universe that had known darkness for so long. Imagine that first generation of stars lighting up the cosmos. The darkness would not have vanished all at once. Instead, small islands of radiance would appear, scattered across the expanding void. Their light would slowly ionize the surrounding gas, transforming the cosmic landscape. It was a gradual awakening, like candles being lit one by one in a great, endless hall. Within these stars, nuclear fusion began shaping heavier elements. Hydrogen fused into helium, releasing energy that made the stars shine. In their cores, pressure and temperature reached astonishing levels. And when some of these massive stars reached the ends of their lives, they exploded as supernovae, scattering newly forged elements into space. Carbon, oxygen, nitrogen, these building blocks of life, were born in stellar hearts. There is something deeply soothing about this slow unfolding. The universe did not rush. It evolved in stages, each one preparing the way for the next. Darkness gave way to light. Simplicity gave way to complexity. And all of it happened in vast stretches of time, measured not in years, but in billions of them. As galaxies began to form, gravity drew stars into swirling systems. Vast spirals, elliptical clusters, and irregular shapes emerged, each containing billions of stars. These galaxies were not isolated. They gathered into clusters, connected by filaments of matter forming a cosmic web. If we could step far outside and look back, we might see a structure resembling delicate threads stretching across unimaginable distances, glowing faintly against deep blackness. And yet, for all its grandeur, the early universe remained mostly empty. Space is astonishingly vast. Even within galaxies, stars are separated by enormous distances. The calm emptiness between them is part of the beauty. Silence dominates. Darkness frames the light. Somewhere within one ordinary galaxy billions of years later, a particular star would form in a quiet spiral arm. Around it, planets would gather from swirling dust. On one of those planets, oceans would shimmer under a young sunday. And eventually, conscious beings would look back through telescopes, studying faint microwave signals and distant galaxies, piecing together the story of that first light. It is remarkable to think that from such an intense and chaotic beginning emerged a universe capable of calm nights and thoughtful observers. The first light did not just illuminate space. It set in motion a chain of events leading to stars, planets, life, and curiosity itself. As you let your mind drift, imagine that ancient glow still traveling, still whispering across the cosmos. It carries no sound, no urgency, only information. A soft echo of beginnings. And tonight, beneath your quiet sky, that same ancient light passes gently through the space around you, a reminder that the universe once awakened from darkness and has been expanding, glowing, and quietly unfolding ever since. If you step outside on a clear night and gaze upward, the stars appear steady and complete, as though what you see is the whole story. The glowing band of the Milky Way stretches softly across the sky. Planets wander gently among the constellations, and distant galaxies shimmer like faint pearls scattered in velvet darkness. It feels whole. It feels finished. And yet, what your eyes perceive is only a small fraction of what truly exists. The universe, calm and luminous as it appears, is mostly invisible. Imagine drifting far beyond Earth, leaving behind its atmosphere, its moon, and the familiar warmth of the sun. You pass through the outer edges of our solar system, gliding into interstellar space where stars are separated by vast, silent distances. From here, our galaxy becomes visible in full, a majestic spiral of hundreds of billions of stars, rotating slowly like a cosmic pinwheel. But something about its motion is puzzling. The outer stars, far from the bright center, orbit much faster than they should. According to the laws of gravity, stars far from the galactic core should move more slowly, much like planets in our solar system do as their distance from the sun increases. But observations reveal something unexpected. The stars at the edges of galaxies travel at speeds that defy the visible mass within them. It is as if something unseen is holding them together, preventing them from drifting away into the dark. This unseen presence is called dark matter. It does not emit light. It does not reflect it. It does not absorb it. It simply exists quietly, revealing itself only through gravity. Imagine a vast, transparent scaffolding stretching through space, cradling galaxies in its gentle but powerful grip. Without it, galaxies as we know them might never have formed. Dark matter is not rare. In fact, it outweighs the ordinary matter, the stars, planets, gas, and dust, by a significant margin. All the glowing beauty we see accounts for only a small percentage of the universe's total content. The rest is hidden, like a deep ocean beneath a thin layer of shimmering surface water. As your thoughts float softly through this idea, consider how humbling it is. For centuries, humanity believed the visible world was the full picture. Now we understand that most of the cosmos is composed of something we cannot directly detect. It is as if we have been listening to a symphony while hearing only a few instruments, unaware of the deeper notes resonating beneath. Even more mysterious than dark matter is dark energy, a force that seems to gently push the universe apart. In the late 20th century, astronomers made a startling discovery. Not only is the universe expanding, but its expansion is accelerating. Galaxies are drifting away from each other faster over time, as though space itself is being stretched by an invisible hand. Imagine standing on a vast rubber sheet dotted with glowing points of light. As the sheet stretches, the points move farther apart. Now imagine that stretching slowly speeding up. That is what appears to be happening across the cosmos. Dark energy, whatever it may be, dominates the universe. It makes up the majority of its total energy content, yet remains profoundly mysterious. Some scientists propose that dark energy is a property of space itself, an intrinsic energy woven into the fabric of the cosmos. Others speculate it may be linked to unknown fields or phenomena yet to be discovered. For now, it remains one of the greatest unanswered questions in science, a quiet force shaping the ultimate fate of everything. And what might that fate be? If dark energy continues to accelerate expansion, galaxies will drift farther apart. Over unimaginable spans of time, distant galaxies may slip beyond our observable horizon, their light stretched so thin that it fades into darkness. The night sky, billions of years from now, could appear emptier. The universe may become increasingly cold and isolated. Yet there is something strangely peaceful about this slow unfolding. The cosmos operates on timescales so vast that even its most dramatic changes occur gently. No sudden collapse, no abrupt ending, just a gradual stretching, a slow fading of light across infinite space. Dark matter and dark energy remind us that reality is deeper than appearance. Beneath the visible dance of stars lies a hidden structure guiding cosmic evolution. It is quiet, it does not sparkle, but it shapes everything. Picture, if you will, a galaxy forming in the early universe. Invisible halos of dark matter gather first, pulling in ordinary matter through gravity. Gas collects within these halos, cooling and condensing until stars ignite. Without dark matter's gravitational embrace, those early clouds may never have collapsed. The visible universe owes its beauty to something we cannot see. There is comfort in that idea. It suggests that unseen forces can nurture creation. That silence can support brilliance. That darkness is not merely absence, but foundation. As you breathe slowly and imagine drifting through intergalactic space, you pass through regions where dark matter forms vast filaments connecting clusters of galaxies. These filaments create a cosmic web, an intricate network stretching across billions of light years. If illuminated, it might resemble delicate strands of silver thread woven through the void. And yet, even with advanced instruments, dark matter remains elusive. Experiments deep underground search for faint interactions. Particle accelerators attempt to recreate conditions that might reveal its nature. Space observatories map gravitational lensing, where massive objects bend light from distant galaxies, offering indirect clues. The search continues patiently, much like the universe itself. Each discovery opens new questions. Each answer reveals deeper mysteries. As this section of our journey comes to rest, let your thoughts settle gently on the idea that most of existence is hidden from sight. The night sky you see is only the surface. Beneath it lies an invisible architecture holding galaxies together and guiding cosmic expansion. The universe is not only vast and luminous. It is subtle and quiet, filled with unseen forces that shape its destiny. And as you drift towards sleep, remember that mystery is not something to fear. It is something to wonder about softly, like distant stars shining calmly in an endless, invisible sea. If you look up at the night sky and focus on a single star, it may seem eternal, as though it has always been there and will always remain. Its light feels steady and calm, a tiny anchor in the vast darkness. But stars, like all things in the universe, have stories. They are born, they live long luminous lives, and eventually, they fade or transform in ways both dramatic and beautiful. And in their slow cycles of creation and release, they quietly shape the destiny of everything around them. Imagine drifting through a giant cloud of gas and dust, floating silently in interstellar space. These enormous clouds, called nebulae, can stretch across hundreds of light years. At first, they appear calm and motionless, like cosmic fog illuminated faintly by nearby starlight. But inside them, gravity is always at work. Tiny fluctuations in density slowly grow stronger. Particles drift closer together. Over millions of years, regions within the cloud begin to collapse inward, pulled by their own weight. As the cloud contracts, it spins gently, flattening into a rotating disk. At its center, matter gathers more tightly, pressure rising, temperature increasing. Slowly, almost imperceptibly, a new star begins to form. When the core becomes hot enough, hydrogen atoms start fusing into helium. This fusion releases energy, an outward pressure that balances gravity's inward pull. And just like that, a star is born. The moment of ignition is not explosive like a spark from a flame. It is gradual and powerful, like a deep breath of light filling the surrounding darkness. A new star begins to shine, casting warmth and illumination into the cold vacuum. Around it, leftover material in the disk may gather into planets, moons, asteroids, and comets. Entire solar systems can arise from this quiet process. Our own sun was born this way around 4.6 billion years ago in a modest region of the Milky Way. It is considered an average star, not especially large, not especially small. Yet its steady energy has sustained life on Earth for billions of years. Every sunrise you have ever seen is powered by nuclear fusion happening at the sun's core, where hydrogen atoms merge at extraordinary temperatures, releasing light that travels across space to gently warm our world. Stars spend most of their lives in this balanced state, calmly fusing hydrogen. For massive stars, this stage may last only a few million years. For smaller stars, it can continue for tens or even hundreds of billions of years. The pace depends on size. Larger stars burn hotter and faster, living brilliant but short lives. Smaller stars glow more softly and endure for ages beyond imagination. But even stars cannot shine forever. Eventually, the hydrogen in their cores becomes depleted. Gravity begins to tighten its grip once more. The core contracts and heats up further, allowing helium to fuse into heavier elements like carbon and oxygen. The outer layers expand dramatically. A once modest star can swell into a red giant, growing so large that it may engulf nearby planets. Imagine standing on a distant world, watching your star expand in the sky, growing brighter and redder over time. The transformation would take millions of years, far too slow for any single observer to witness fully. Yet it would be unstoppable. For stars similar in size to the Sun, the ending is gentle. After shedding their outer layers into space, forming beautiful glowing shells known as planetary nebulae, the remaining core cools into a white dwarf. This dense, Earth-sized remnant slowly fades over billions of years, radiating residual heat into the darkness. More massive stars meet far more dramatic fates. When their cores begin fusing heavier elements, they eventually produce iron, an element that cannot release energy through fusion. Without outward pressure to counter gravity, the core collapses suddenly. In a fraction of a second, the star implodes and then rebounds in a titanic explosion called a supernova. A supernova briefly outshines entire galaxies. It sends shockwaves racing outward, scattering heavy elements into space. Gold, silver, uranium, many of the elements we value on Earth were forged in these violent stellar deaths. It is a powerful and humbling thought that the atoms within your body may once have been hurled across the cosmos in such an explosion. After the supernova, what remains depends again on mass. Some cores compress into neutron stars, incredibly dense objects where matter is packed so tightly that a teaspoonful would weigh billions of tons. Others collapse further into black holes, regions where gravity becomes so intense that not even light can escape. And yet, even in these endings, there is continuity. The material ejected from dying stars enriches surrounding clouds of gas. Those enriched clouds form new generations of stars and planets. The cycle begins again. Birth, life, transformation, release. There is something deeply soothing about this cosmic rhythm. Stars are not static decorations in the sky. They are dynamic participants in an endless process of renewal. They light up darkness, create complexity, and return their substance to space so that something new may form. As you imagine drifting peacefully between stars, notice how far apart they are. Despite the brilliance we see from Earth, space is mostly empty. The nearest star beyond the Sun is over 4 light-years away. That distance is so vast that even light, traveling at incredible speed, takes years to cross it. The quiet between stars is profound. No sound carries. No wind blows. Only gravity and radiation shape the slow ballet of celestial bodies. And within this immense stillness, stars continue their patient lives, glowing steadily for eons. Tonight, as you settle into rest, consider the star above you that feels constant and dependable. It too has a story stretching across billions of years. It was born from dust. It will one day return to dust. And in its steady shining, it has made life possible. The universe does not rush its creations. It allows stars to form slowly, to live brightly, and to end in ways that seed future beginnings. And somewhere in that endless, silent cycle, you exist, a conscious piece of stardust, quietly observing the gentle rise and fall of cosmic light. Somewhere in the silent depths of space, far beyond the reach of ordinary sight, there are places where gravity becomes so strong that even light cannot escape. These places are not loud, not fiery, not constantly devouring everything around them as dramatic stories sometimes suggest. Instead, they are quiet, patient, almost invisible against the backdrop of stars. They are black holes, and despite their intimidating name, they are among the most fascinating and mysterious objects in the universe. Imagine drifting gently toward the center of a distant galaxy. Stars orbit gracefully in vast spirals, glowing like scattered lanterns. As you move closer to the core, their density increases. The light becomes more concentrated, and hidden within that luminous center, there may lie a supermassive black hole, millions or even billions of times heavier than our sun. It does not glow on its own. It does not announce its presence. Yet its gravity holds the galaxy together, guiding the motion of billions of stars in a silent cosmic dance. Our own galaxy, the Milky Way, contains such a giant at its heart. For years, astronomers observed stars near the center moving at incredible speeds, tracing tight orbits around something unseen. Only a tremendously massive and compact object could explain their motion. And so, in the quiet darkness, we learned that a supermassive black hole rests there, calm and powerful. Black holes are born from the death of massive stars. When a very large star exhausts its nuclear fuel, its core collapses under gravity's relentless pull. If the remaining mass is great enough, nothing can stop the collapse. The core compresses beyond the size of a neutron star, shrinking to an incredibly tiny point of immense density. Around this core lies a boundary known as the event horizon, the point of no return. Cross this invisible line, and escape becomes impossible. Yet black holes are not cosmic vacuum cleaners randomly sweeping up everything in their path. If our sun were replaced by a black hole of equal mass, Earth would continue orbiting as before, though without warmth or light. the gravitational pull at a distance would remain the same. It is only when you approach very close that their true intensity becomes clear. Imagine approaching a black hole slowly, carefully, drifting through a silent sea of stars. From far away, it appears as a dark sphere surrounded by a glowing disk of swirling gas. This disk forms as nearby material spirals inward, heating up and radiating brilliant light before crossing the event horizon. The glow can be dazzling, sometimes outshining entire galaxies. Yet the black hole itself remains dark, defined not by what it shows, but by what it hides. Time behaves strangely near a black hole. According to Einstein's theory of general relativity, gravity bends not only space but time itself. The stronger the gravity, the slower time flows. Near the event horizon, time would stretch dramatically. To a distant observer, an object falling toward a black hole would appear to slow down, its light redshifting and fading, never quite crossing the boundary. From the object's own perspective, however, it would pass through without noticing a dramatic barrier. There is something deeply mysterious about this relationship between gravity and time. It suggests that reality is more flexible than our everyday experience implies. Space can curve, time can stretch, and black holes are places where these effects become extreme. Some black holes are relatively small, perhaps only a few times the mass of our sun. Others are colossal, residing at the centers of galaxies. How these supermassive black holes formed remains an open question. Did they grow slowly by consuming matter and merging with other black holes? Or did they form rapidly in the early universe from enormous collapsing clouds of gas? The answers are still unfolding. In 2019, humanity saw the first direct image of a black hole's shadow, a glowing ring surrounding a dark center. It was not a photograph in the traditional sense, but a composite image built from radio signals collected by telescopes spread across Earth. The image revealed a circular silhouette, confirming decades of theoretical predictions. It was a quiet triumph, proof that even the darkest objects can be studied with patience and creativity. But black holes are not merely endpoints. They may also play a role in shaping galaxies. The energy released as matter falls into a supermassive black hole can influence star formation, regulating the growth of its host galaxy. In this way, black holes act less like destroyers and more like guardians, maintaining balance on cosmic scales. There are even deeper mysteries. At the very center of a black hole lies what physicists call a singularity, a point where density becomes infinite and the known laws of physics break down. What truly happens there? Does matter compress into an unimaginably small state? Could black holes connect to other regions of space or even other universes? These ideas remain speculative, drifting at the edge of theoretical exploration. As you let your thoughts slow and soften, imagine floating safely at a distance from one of these dark giants. Stars shimmer quietly around you. The glowing accretion disk swirls like a luminous river, bending light into arcs due to extreme gravity. It is beautiful in its own way, not frightening, but awe-inspiring. The universe contains both radiant stars and silent black holes. Light and darkness exist side by side, each shaping the other. And perhaps that balance is part of the comfort. Even in the deepest dark, there is structure. Even in regions where light cannot escape, the laws of nature continue their work. Black holes remind us that mystery is not emptiness. It is depth. It is the recognition that there are layers of reality still waiting to be understood. And as you drift toward rest, imagine the vast cosmos continuing its quiet dance, galaxies orbiting unseen centers, stars forming and fading, gravity gently sculpting space and time. In that immense and silent universe, black holes remain still, patient, and powerful, not as monsters of chaos, but as quiet guardians of the dark. After a massive star lives its bright and brilliant life, after it swells and burns through heavier and heavier elements in its core, there comes a moment when gravity finally wins. The star can no longer support its own weight. In an instant that is both violent and strangely beautiful, it collapses and explodes in a supernova, scattering its outer layers across space in a radiant burst of light. But sometimes what remains at the center is not a black hole. Sometimes, the core compresses into something almost unimaginable, a neutron star. Imagine a star many times larger than our Sun shrinking down to the size of a city. Not gradually, not gently, but in a rapid collapse where protons and electrons are crushed together, merging into neutrons. The result is an object so dense that a single teaspoon of its material would weigh billions of tons on Earth. And yet, despite this incredible density, neutron stars are small, only about 20 kilometers across. Silent, almost invisible in the vastness of space. If you could float safely nearby, keeping a respectful distance, you would see something that appears calm from afar. A faint sphere, perhaps glowing softly with residual heat, spinning rapidly in the dark. But its gravity would be extraordinary. Step too close, and the difference in gravitational pull between your feet and your head would be extreme. The surface gravity of a neutron star is billions of times stronger than Earth's. And yet, even here in this realm of extreme physics, there is a kind of quiet beauty. Neutron stars are cosmic remnants, the compressed hearts of once mighty suns. They carry within them the memory of stellar fusion, of nuclear fire that once illuminated surrounding planets. Now they exist in a new state, stabilized not by thermal pressure, but by something known as neutron degeneracy pressure, a quantum mechanical effect that prevents the neutrons from being squeezed any closer together. Some neutron stars spin astonishingly fast. When the core of a star collapses, its rotation speeds up, much like a figure skater pulling in their arms. A massive star that once rotated slowly can become a neutron star spinning dozens or even hundreds of times per second. As it spins, it can emit beams of radiation from its magnetic poles. If these beams sweep across Earth, we detect regular pulses, like a cosmic lighthouse. These objects are called pulsars. Picture drifting in deep space and witnessing this steady pulse of energy, flashing rhythmically against the dark backdrop. Some pulsars are so precise in their timing that they rival atomic clocks. Their steady signals have allowed scientists to test theories of gravity and even detect subtle ripples in space-time known as gravitational waves. Gravitational waves are another gentle whisper of the cosmos. When two neutron stars orbit one another closely, they gradually spiral inward, losing energy as faint waves that ripple through space itself. When they finally collide, the event releases an enormous burst of energy and creates heavy elements such as gold and platinum. These collisions are rare and distant, but their impact echoes across the universe. Pause for a moment and imagine that the gold in a ring or necklace may have formed during such a collision billions of years ago, when two neutron stars merged in a brilliant explosion far from our galaxy. The atoms journeyed across space, eventually becoming part of a cloud that formed our Sun and planets. In this way, even the densest and most extreme objects contribute to the gentle unfolding of life. Neutron stars also possess magnetic fields trillions of times stronger than Earth's. In certain cases, these magnetic fields twist and strain the star's crust, causing sudden releases of energy known as starquakes. These events can send bursts of gamma rays across the cosmos. Yet even these powerful outbursts are swallowed by distance and silence long before reaching us. There is something deeply humbling about neutron stars. They represent the limits of matter as we understand it. They exist at the boundary between ordinary stars and black holes. Add just a little more mass, and even neutron degeneracy pressure would fail, collapsing the object further into darkness. They stand as delicate balances between gravity and quantum mechanics. Imagine standing on the surface of such a star, though in reality, you could not survive. The landscape would be unlike anything familiar. The crust, only about a kilometer thick, would be solid and unimaginably hard. The sky above would be black, pierced by distant stars. And beneath your feet would lie matter compressed to extremes beyond earthly experience. And yet, despite their exotic nature, neutron stars are part of a larger story. They are not isolated curiosities. They are chapters in the ongoing evolution of galaxies. Their supernova births seed space with elements. Their mergers shape cosmic chemistry. Their pulses help us measure the universe. As your thoughts begin to slow, imagine drifting quietly between stars once more. Somewhere in the distance, a neutron star spins in silence, its beams sweeping through space like gentle signals in the dark. No sound carries, no dramatic music plays, only the steady rhythm of physics unfolding across unimaginable distances. The universe, even in its most extreme forms, maintains a kind of balance. From vast expanding galaxies to tiny, ultradense remnants, each object plays its role. Neutron stars remind us that collapse does not always lead to disappearance. Sometimes it leads to transformation, into something smaller, denser, but still enduring. And so, in the deep quiet of space, these compact stars continue their silent rotations, carrying within them the compressed memory of ancient suns. They spin patiently, surrounded by darkness, contributing to a universe that is both powerful and profoundly calm. If you could rise gently above the Milky Way and look back at it from far beyond its spiral arms, you might first feel a sense of completion. Billions of stars swirling in elegant curves, glowing gas clouds drifting like soft cosmic mist, dark lanes of dust weaving intricate patterns through luminous light. It would seem immense, self-contained, almost like an entire universe on its own. But then, as you drift farther still, something astonishing would begin to reveal itself. The Milky Way is not alone. It is only one island in an incomprehensibly vast ocean of galaxies. Imagine floating in the quiet between galaxies. The darkness here is deeper than anything experienced on Earth. Stars are no longer scattered richly across your vision. Instead, you see distant spirals, ellipticals, and irregular shapes glowing faintly, each one a city of stars far beyond counting. Some are graceful pinwheels. Others are smooth and oval, like glowing embers suspended in space. Some appear distorted, stretched by gravity into delicate arcs. Each galaxy may contain billions or even trillions of stars. Around many of those stars, planets may quietly orbit. Around some of those planets, perhaps oceans shimmer beneath alien skies. And yet, the distances between galaxies are enormous. Even light, traveling at its ultimate speed, takes millions of years to cross from one to another. Our Milky Way belongs to a small collection of galaxies known as the Local Group. This group includes the Andromeda Galaxy, a majestic spiral slightly larger than our own, drifting slowly toward us. Though that movement sounds dramatic, the eventual encounter will not occur for billions of years. And when it does, it will unfold slowly, gracefully, as two vast star systems interweave. Individual stars will likely pass by one another without collision due to the immense distances between them. The galaxies will merge in a silent ballet lasting hundreds of millions of years. Now imagine pulling back even farther. The Local Group itself is part of a larger gathering known as a galaxy cluster. These clusters contain hundreds or thousands of galaxies bound together by gravity. And beyond clusters lie superclusters, enormous structures stretching across hundreds of millions of light years. When astronomers map the distribution of galaxies across the observable universe, they discover something remarkable. Galaxies are not scattered randomly. They form a vast cosmic web. This web consists of filaments of galaxies and dark matter stretching across space, with enormous voids between them. The voids are not completely empty, but they are far less populated. The overall pattern resembles delicate lace or the branching networks of neurons in a brain. It is as if the universe has woven itself into a grand structure, balanced between density and emptiness. There is something soothing in this immense scale. Human worries, daily rhythms, even entire civilizations feel small against such a backdrop. Yet small does not mean insignificant. Every galaxy in this web carries within it countless stories of star birth, of planetary formation, of cosmic evolution. Some galaxies are calm and orderly, with well-defined spiral arms rotating steadily. Others are chaotic, shaped by past collisions and gravitational encounters. When galaxies pass close to one another, tidal forces can stretch their stars into long streams. Gas clouds may compress, triggering bursts of star formation. Entire new stellar nurseries can ignite as a result of these interactions. Picture drifting between two galaxies in the midst of a slow collision. Streams of stars arc gracefully through space. Clouds of gas glow softly in new patterns. The process is not violent in the way explosions are violent. It is slow and majestic, unfolding over eons. The silence remains absolute. Only gravity orchestrates the movement. At the centers of most large galaxies lie supermassive black holes, quietly anchoring their hosts. These central giants can influence star formation, sometimes releasing jets of high-energy particles that extend far beyond the galactic core. Even so, much of galactic life proceeds calmly. Stars are born, live, and fade. Planetary systems assemble and evolve. Light travels outward, carrying information across time. When we observe distant galaxies, we are also looking into the past. Because light takes time to travel, a galaxy 1 billion light-years away is seen as it was 1 billion years ago. The deeper we look into space, the younger the universe appears. In this way, telescopes act as time machines, allowing us to witness earlier stages of cosmic history. Some of the most distant galaxies appear small and faint, their light stretched into redder wavelengths by cosmic expansion. These early galaxies were less structured, still assembling from smaller building blocks. Over billions of years, gravity shaped them into the grand spirals and massive ellipticals we see today. And yet, even as we map millions of galaxies, we can only observe a limited portion of the universe, the observable universe. Beyond that boundary lies more space, more galaxies, perhaps infinitely many. We cannot see beyond the distance light has had time to travel since the beginning of cosmic expansion. There may be structures beyond our horizon that we will never know. As your thoughts drift gently through this vastness, imagine hovering at a point where countless galaxies surround you in all directions. Each glows softly, separated by oceans of darkness. The scene is not chaotic. It is balanced. It is spacious. The silence is profound. The universe is not merely a scattering of stars. It is an intricate, large-scale tapestry of galaxies connected by invisible threads of gravity and dark matter. From our small vantage point within one spiral arm of one galaxy, we are part of something almost unimaginably grand. And yet, despite its scale, the cosmic web unfolds patiently. Galaxies drift slowly. Clusters evolve gradually. Light crosses space at its steady speed. There is no rush, no urgency, only the continuous expansion of a universe that began with a flash of light and has since blossomed into a vast ocean of glowing islands. As you settle deeper into rest, picture the Milky Way glowing softly among billions of companions. Somewhere within it, on a small blue world, you exist, aware, reflective, quietly contemplating the infinite ocean of galaxies that stretches far beyond the reach of sight, calm and luminous in the endless night. As you lie beneath the night sky and let your thoughts drift beyond the familiar stars, there is a gentle question that has echoed through human imagination for centuries. Are we alone? It is a question that does not demand urgency. It does not rush for an answer. Instead, it lingers softly, like a distant light barely visible at the edge of vision. And in recent decades, that faint light has grown brighter as we have discovered something extraordinary: planets orbiting other stars. For most of history, we only knew of the planets in our own solar system. Mercury circling close to the Sun, Jupiter massive and majestic, Saturn wrapped in its rings. These worlds felt special, perhaps even unique. But as technology advanced and telescopes became more sensitive, astronomers began detecting subtle changes in the light of distant stars. A slight dimming, repeating at regular intervals. A gentle wobble in a star's motion. Small clues that something unseen was orbiting around it. These unseen companions came to be known as exoplanets, planets beyond our solar system. The first confirmed discoveries in the 1990s opened a doorway to a new understanding. Since then, thousands have been identified, and with each new world catalogued, the universe has felt a little less empty. Imagine drifting toward a distant star system hundreds of light years away. From afar, the star glows like a tiny ember. But as you approach, you begin to see planets circling it, each with its own character. Some exoplanets are massive gas giants, far larger than Jupiter, orbiting so close to their stars that their atmospheres are heated to extreme temperatures. Others are rocky worlds, similar in size to Earth, resting in what astronomers call the habitable zone, the region where liquid water could potentially exist. There are planets made largely of water, where vast global oceans may stretch without interruption. There are worlds with thick atmospheres of hydrogen and helium. Some orbit binary stars, where two suns rise and set in alien skies. Others travel on elongated paths, experiencing dramatic changes in temperature as they swing close to and far from their stars. Picture standing, safely in imagination, on the surface of one such world. The sky above you might glow orange beneath a red dwarf star, smaller and cooler than our sun. The light would feel dimmer, the shadows softer. Or perhaps you stand on a planet orbiting two stars, where twin suns cast overlapping halos of light across a rocky plain. These possibilities are no longer confined to science fiction. They are grounded in observation. One of the most remarkable discoveries has been the sheer variety of planetary systems. Our solar system once seemed like a template, but exoplanets have shown us that nature is far more creative. Some systems contain hot Jupiters, gas giants that orbit incredibly close to their stars, completing a full revolution in just days. Others feature compact arrangements where multiple rocky planets circle tightly packed near their sun. And among these thousands of worlds, a few resemble Earth in size and distance from their stars. Scientists carefully analyze their atmospheres when possible, searching for chemical signatures that might hint at biological activity. Oxygen, methane, water vapor. These molecules can provide subtle clues. So far, no definitive evidence of life has been found beyond Earth. Yet the possibility remains open, quietly waiting. Consider how vast the Milky Way alone is, containing hundreds of billions of stars. If even a small fraction host planets, and a small fraction of those reside in habitable zones, the number of potentially life-supporting worlds becomes significant. Extend that thought to the billions of galaxies beyond our own, and the possibilities expand beyond comfortable comprehension. And yet, the universe remains silent. Despite decades of listening for radio signals or other technological signs from distant civilizations, we have detected no clear message. This silence is sometimes called the Great Silence, and it deepens the mystery rather than diminishing it. Perhaps intelligent life is rare. Perhaps civilizations rise and fade quickly. Or perhaps the cosmos is teeming with life that simply communicates in ways we have not yet learned to detect. There is something peaceful about this uncertainty. The universe does not rush to reveal its secrets. It allows us to explore slowly, step by step. Each new telescope, each improved instrument, brings the faint glow of distant planets into clearer focus. Imagine drifting between stars once more, passing through regions where planetary systems quietly orbit their suns. On some worlds, volcanic activity shapes rugged landscapes. On others, thick clouds conceal oceans beneath. Some may be frozen spheres wandering far from any star, their surfaces locked in eternal night. Each world carries its own story, unfolding over millions or billions of years. Even within our own solar system, moons such as Europa and Enceladus may harbor subsurface oceans beneath icy crusts. If life can emerge in such hidden places, then the range of possible habitats widens further. The boundaries of where life might exist continue to expand gently outward. As your breathing slows, let yourself imagine that somewhere in this immense cosmic ocean, another being may look up at its own sky, wondering the same quiet question about companionship in the universe. Perhaps they too see a band of stars across the darkness. Perhaps they too feel both small and connected to something vast. The discovery of exoplanets has transformed the night sky from a scattering of distant lights into a map of potential worlds. It has shifted our understanding from uniqueness to possibility. We are no longer standing alone on a solitary island. We are part of a galaxy filled with countless shores. And yet, for now, Earth remains the only world we know that carries life. That knowledge adds a gentle sense of responsibility. Our planet, with its oceans, forests, and atmosphere, is precious. It is a rare oasis in the immense desert of space. As you drift toward sleep, Imagine the quiet procession of planets orbiting distant stars. Each moves in steady rhythm, guided by gravity, bathed in starlight. Some are harsh and unwelcoming. Others may be gentle and temperate. And somewhere among them, perhaps, life stirs softly beneath unfamiliar skies. The universe does not answer quickly. It unfolds slowly, offering glimpses of possibility. And tonight, as you rest beneath your own familiar sky, remember that beyond the stars you see lie countless other worlds, silent, mysterious, and full of quiet potential in the endless cosmic night. Close your eyes for a moment and imagine holding a clock unlike any other. This clock does not measure seconds, minutes, or hours. It measures billions of years. Its ticking is so slow that entire civilizations would rise and fall between each gentle movement of its hand. This is cosmic time, the vast timeline across which the universe has unfolded, patient and unhurried, stretching back nearly 13.8 billion years. If we compress the entire history of the universe into a single calendar year, something remarkable happens. The Big Bang occurs at midnight on January 1st. Galaxies begin forming within the first few months. Our Milky Way takes shape sometime in early spring. The Sun and Earth do not appear until early September. Dinosaurs roam only in the last week of December. And all of recorded human history occupies just the final seconds before midnight on December 31st. In this perspective, our existence is breathtakingly brief, a fleeting whisper in an ancient cosmic story. Yet brevity does not mean insignificance. It simply means we are part of a much larger unfolding. The universe began in an intense state of heat and density, expanded rapidly, cooled gradually, and formed structure over immense stretches of time. Stars ignited, galaxies assembled, heavy elements formed, and eventually planets emerged. Each step required patience measured in millions and billions of years. Imagine drifting backward through time, watching galaxies shrink closer together as cosmic expansion reverses in your imagination. Stars grow younger, nebulae become more common, the first galaxies appear as faint clusters of light. Continue traveling further back, and even those structures dissolve into a glowing, uniform plasma. The deeper you go, the simpler everything becomes, until you approach that early moment of blinding energy and potential. Now drift forward again, but slowly. Watch as the first stars ignite, their light piercing the darkness of the early universe. See galaxies begin to rotate, gravitationally bound yet expanding apart from one another. Observe clusters forming, merging, evolving. Notice how time smooths the violent into the serene. Supernovae explode, but their shockwaves eventually fade into quiet interstellar clouds. Collisions between galaxies settle into new, stable shapes. Cosmic time softens everything. Even the most dramatic events are stretched across durations so vast that they appear gentle when viewed from afar. The universe does not hurry. Gravity works patiently. Expansion continues steadily. Entropy, the gradual movement toward disorder, increases slowly, shaping the long-term destiny of all structures. Consider our sun. It has been shining for about 4.6 billion years and will continue for roughly another 5 billion. To human perception, that span feels infinite. Yet in cosmic terms, it is a chapter with a beginning, middle, and end. One day, long in the future, the sun will expand into a red giant, altering the inner solar system before settling into a quiet white dwarf stage. Beyond that, even more distant futures unfold. Galaxies will continue drifting apart due to dark energy. Star formation will gradually slow as available gas becomes scarce. After trillions of years, the universe may enter an era dominated by faint stellar remnants, white dwarfs, neutron stars, and black holes. Eventually, even black holes may evaporate over unimaginable spans of time through a process known as Hawking radiation, slowly releasing their mass as faint energy. This projected future is sometimes called the heat death of the universe, a state where energy becomes evenly distributed and no more work can be done. It sounds dramatic, but it would occur so gradually that there would be no sudden end. Only an endless fading into equilibrium, a gentle cooling towards stillness. Yet these timescales stretch so far beyond our current age that they feel almost abstract. For now, the universe remains vibrant. Stars continue to form. Planets continue to orbit. Galaxies continue their quiet interactions. What makes cosmic time especially beautiful is that it connects everything. The atoms in your body were forged in ancient stars billions of years ago. The oxygen you breathe was once part of a stellar core. The iron in your blood originated in supernova explosions long before Earth existed. In this way, your presence is the continuation of cosmic history. Imagine floating in space and watching a single hydrogen atom journey through time. It forms shortly after the Big Bang. It drifts for millions of years before being pulled into a star. It participates in fusion, becomes part of a heavier element, is expelled in a supernova, drifts again, becomes part of a molecular cloud, joins a forming planet, and eventually becomes part of a living organism. The atom's timeline spans billions of years, yet it moves without awareness, guided only by physical laws. We, however, are aware. We can look back and reconstruct this immense timeline through observation and theory. Telescopes allow us to peer into distant space and thus into earlier times. Geological records preserve the story of Earth's formation and evolution. Physics provides models that describe conditions moments after cosmic expansion began. There is something deeply comforting about knowing the universe has a history. It was not static. It has changed, evolved, matured, and it continues to change. Even now, as you rest and breathe, the Earth spins, the Moon orbits, the Sun radiates energy, and the Milky Way rotates around its center. Cosmic time reminds us that change is natural and constant. Nothing remains exactly as it is forever. Stars are born and fade. Galaxies merge and separate. Even the universe itself expands. As you let your thoughts drift toward sleep, imagine that immense cosmic clock ticking softly. Not loudly, not urgently, but steadily. Each moment carries forward a story billions of years in the making. And within that vast expanse of time, your life unfolds, brief but luminous, a conscious spark in a universe that has been evolving patiently for nearly 14 billion years. The deep history of everything is not distant or disconnected. It lives within you, within every atom, within every breath. And as the universe continues its slow, graceful journey through time, you are part of its ongoing story, quietly aware beneath the endless stars. There is a force in the universe so gentle that you rarely notice it, yet so powerful that it shapes the motion of galaxies. It holds your feet to the Earth, guides the Moon in its orbit, steers planets around stars, and binds entire clusters of galaxies across unimaginable distances. This force does not shine or shimmer. It has no color, no scent, no sound. And yet it is everywhere. It is gravity, the quiet architect of the cosmos. Imagine releasing yourself into open space, far from Earth's pull. You would float effortlessly, weightless and calm. But even there, gravity has not disappeared. It is simply weaker. Every object with mass exerts a gravitational influence on every other object. The force may be subtle, but it never truly vanishes. It extends infinitely, reaching outward through the darkness. Gravity is the reason stars form. In vast molecular clouds drifting between the stars, particles of gas slowly draw toward one another under their mutual attraction. Over millions of years, the cloud contracts, heating as it compresses, eventually igniting nuclear fusion. Without gravity's steady pull, the universe would remain a thin, uniform fog. There would be no stars, no planets, no galaxies, only scattered particles drifting aimlessly. Picture the Earth suspended in space, held in orbit around the Sun not by strings or solid tracks, but by the curvature of space-time itself. According to Einstein's theory of general relativity, gravity is not simply a force pulling objects together. It is the bending of space and time caused by mass and energy. The Sun creates a gentle curve in the fabric of space-time, and Earth follows that curve naturally, like a marble rolling along the surface of a stretched sheet. This bending does not only affect planets. Light itself follows curved paths near massive objects. When distant starlight passes near a galaxy cluster, its path bends, creating distorted arcs or even multiple images of the same background galaxy. This phenomenon, known as gravitational lensing, allows astronomers to measure the distribution of mass, even dark matter, within clusters. Gravity works quietly without drama. It does not need explosions or flashes of brilliance to exert influence. It acts continuously, shaping the large-scale structure of the universe. The cosmic web of galaxies exists because gravity gathered matter into filaments and clusters over billions of years. Supermassive black holes dominate galactic centers because gravity compressed enormous amounts of matter into tiny regions. And yet, gravity is also the weakest of the fundamental forces at small scales. A simple magnet can lift a paperclip against the entire gravitational pull of the Earth. This contrast is one of physics' most curious puzzles. Why is gravity so weak compared to other forces, yet so dominant across cosmic distances? Scientists continue to explore this question, seeking deeper understanding. Imagine standing on the surface of the moon. You would feel lighter, able to leap higher with each step. The moon's gravity is weaker because it has less mass than Earth. On Jupiter, by contrast, gravity is much stronger. Your weight would increase significantly, though standing on its gaseous surface would not be possible in any familiar sense. Gravity governs not only motion but also stability. It keeps Earth's atmosphere from drifting into space. It maintains the orbits of moons and rings. It organizes matter into spheres, since gravity pulls equally toward the center. That is why planets and stars are round. Consider the gentle balance that allows Earth to remain habitable. Our distance from the Sun is stabilized by gravity. Too close and oceans would evaporate. Too far and they would freeze. The Moon's gravitational influence stabilizes Earth's axial tilt, moderating seasonal variations. Tides rise and fall because of the Moon's pull, subtly shaping coastal ecosystems. Gravity also guides the slow interactions between galaxies. When two galaxies approach one another, their mutual attraction distorts their shapes, drawing out long streams of stars and gas. Over time, they merge, forming new structures. This process is not violent in the human sense. It unfolds over hundreds of millions of years, guided solely by gravity's steady influence. In the most extreme environments, gravity reveals its profound nature. Near a black hole, space-time curves so deeply that escape becomes impossible. Near neutron stars, gravity compresses matter to astonishing densities. In the early universe, gravity amplified tiny fluctuations in density, eventually leading to the formation of galaxies. And yet, despite its cosmic significance, gravity feels gentle in everyday life. It pulls a leaf toward the ground. It keeps oceans resting against shorelines. It allows rain to fall softly from clouds. It anchors you comfortably to the surface of your planet. There is something comforting about this constancy. Gravity does not fluctuate wildly. It does not vanish unexpectedly. It is dependable, shaping motion in predictable ways. The equations describing gravity allow spacecraft to navigate billions of kilometers with remarkable precision. As you drift toward rest, imagine watching the solar system from afar. Planets trace graceful ellipses around the sun. Comets sweep inward and outward along elongated paths. Moons orbit their planets in intricate patterns. Everything moves in harmony, guided by invisible curves in spacetime. Now imagine zooming outward even farther. The Milky Way rotates slowly, stars orbiting its central black hole. Beyond, galaxy clusters drift within superclusters, bound together by gravity's reach. And on the largest scales, gravity competes with dark energy, one pulling inward, the other driving expansion outward. The universe is a balance between attraction and expansion, between gathering and dispersing. Gravity plays its role patiently, shaping structures from the smallest asteroid to the largest galactic cluster. Tonight, as you lie beneath the sky, gravity holds you gently to the Earth. The same force binds the Earth to the Sun to the galaxy, and the galaxy to its cluster. It connects everything across space and time. In its quiet way, gravity is the thread that weaves the cosmos together, unseen, unwavering, guiding the eternal dance of stars in the vast and silent night. As you drift softly through thought, imagine the universe speaking in a language that is inaudible to human ears. It does not shout or clamor for attention. Instead, it whispers. This whisper comes in the form of cosmic radiation, faint streams of energy that travel across the cosmos, carrying secrets of events long past. Though invisible, these signals permeate space, a gentle reminder that the universe is alive with subtle activity. There are several types of cosmic radiation. Some originate from our own sun, in the form of solar wind, a soft, continuous flow of charged particles drifting outward through the solar system. These particles interact with Earth's magnetic field, creating ethereal auroras that shimmer across polar skies. Watching the northern or southern lights is like witnessing the sun's quiet energy painted across our atmosphere. Beyond the solar wind, there exists radiation from distant stars and supernovae. These particles, known as cosmic rays, travel across interstellar space at near light speed. When they reach Earth, they are mostly deflected by the planet's magnetic field, though some penetrate the atmosphere, creating showers of secondary particles that cascade down gently. Invisible to our eyes, these particles have been traveling for millions or even billions of years before touching our world. Now imagine drifting further into space, beyond the protective cocoon of the solar system. Cosmic rays strike your imaginary spacecraft from all directions, a subtle rain of energy originating from distant stellar explosions. Each particle carries a story: the death of a star, the formation of heavy elements, the shaping of interstellar clouds. Though tiny, they are messengers from events that occurred long before humanity even existed. Even older than these cosmic rays is the cosmic microwave background, the residual heat of the Big Bang itself. Imagine a faint glow suffusing every corner of space, a whisper of the universe's birth, now stretched into microwaves by cosmic expansion. Detected by sensitive instruments, this background provides a snapshot of the cosmos when it was merely 380,000 years old, a newborn, glowing faintly after its first expansion. It is the ultimate gentle echo, a signal that has traveled almost 14 billion years to reach us. These invisible flows of energy remind us that the universe is in constant motion, even in places that appear still. Stars are shining, galaxies are rotating, and radiation streams across the void. Yet none of it feels urgent. It is all part of a slow, majestic unfolding, moving at speeds and scales far beyond human perception, yet accessible through careful observation and patient study. Consider the effect of cosmic radiation on planets. High-energy particles can strip atmospheres over eons, shape the chemistry of surfaces, or trigger subtle changes in organic molecules. On Earth, our magnetic field and atmosphere provide a gentle shield, allowing life to flourish safely beneath. But in other places, the radiation may be harsher, shaping worlds in ways that are alien and unseen. Some cosmic rays originate from enigmatic sources such as pulsars, black holes, or even the far reaches of intergalactic space. These distant accelerators hurl particles across billions of light years, their paths gently curved by the invisible web of magnetic fields threading the universe. Each particle, traveling almost imperceptibly, carries with it a trace of its origin, a soft signature of ancient cosmic events. Even in our daily lives, cosmic radiation leaves a subtle mark. Trace amounts pass through our bodies constantly, a gentle reminder of our connection to the cosmos. Every atom of oxygen, carbon, and nitrogen that makes up our bodies has journeyed through stars and space, interacting with particles that have traveled across time and distance almost beyond imagination. As you let your mind float in this quiet, imagine drifting among galaxies, with faint cosmic rays streaming past you from every direction. Their energy is invisible, yet their presence is constant. They are the universe's quiet messengers, reminding us that even in apparent stillness, the cosmos is vibrant, connected, and ancient. There is something soothing about this awareness. The universe does not need to shout. Its messages arrive gently, over millions and billions of years. They whisper of creation, of transformation, and of enduring structure. They tell us that space is never truly empty, that energy flows silently, and that even the most subtle phenomena have a story to tell. As you settle deeper into rest, imagine these streams of energy moving past you, unhurried and continuous. Each particle, each photon, carries a fragment of cosmic history. Together, they form a quiet background symphony, a gentle hum of existence that fills the universe without demanding attention. Cosmic radiation is the whisper of time and space, the soft voice of stars, explosions, and creation itself. And as you drift towards sleep, let yourself be cradled by this silent symphony, part of a universe that moves patiently, gently, and endlessly in the vast darkness. As you continue your gentle journey through space, imagine drifting into a realm where most of what exists is invisible. Stars, planets, and galaxies glow and shine, but they are only a small fraction of the total cosmic tapestry. The rest is hidden, unseen, yet it exerts a quiet, pervasive influence. This is dark matter, the mysterious substance that shapes the universe without ever revealing itself to our eyes. Dark matter cannot be seen with telescopes. It does not emit, absorb, or reflect light. It does not radiate heat, and yet, its presence is inferred through gravity. Without it, galaxies would not hold together. Stars at the edges of spiral galaxies would fly outward, unbound, leaving the galaxy to dissolve. Instead, something unseen keeps galaxies coherent, gently guiding stars in their orbits. Imagine floating outside a spiral galaxy, observing its graceful arms of stars. You might expect the stars at the edges to drift slowly, but they move far faster than the visible mass can account for. The invisible pull of dark matter forms a halo around the galaxy, an unseen scaffold holding the luminous matter in place. It is silent, calm, and omnipresent, providing the structure upon which the universe builds. Dark matter also plays a role in the cosmic web. Galaxies are not scattered randomly. They trace vast filaments of invisible material stretching across space, forming nodes where clusters gather and voids where little exists. The universe's large-scale structure is a delicate balance of visible and invisible, with dark matter acting as the quiet framework for everything else. Even though it is invisible, dark matter shapes the paths of light. Gravitational lensing occurs when light from a distant galaxy bends around concentrations of mass, both visible and unseen. By studying these distortions, astronomers can map the distribution of dark matter, revealing its gentle but undeniable presence across cosmic scales. Despite its pervasiveness, the true nature of dark matter remains one of science's most profound mysteries. It may be composed of exotic particles that barely interact with ordinary matter. It may even hint at new physics beyond the standard theories we know. For now, it remains invisible, yet its gravitational fingerprint is clear, stretching through every galaxy, every cluster, every corner of the cosmos. Imagine drifting through a cluster of galaxies, the dark matter halo enveloping you in silent gravity. You feel no pull directly, yet you sense that your path is shaped by something unseen. Stars shimmer brightly in the foreground, gas clouds glow softly, but the invisible mass surrounds and structures everything, patient and constant. Dark matter also influences the formation of galaxies. In the early universe, slight fluctuations in density attracted ordinary matter, drawing gas and dust into the growing gravitational wells formed by dark matter. Slowly, over millions of years, stars ignited and galaxies emerged, shaped by this hidden framework. Without dark matter, the universe might have remained an unstructured, dimly glowing fog. Some theories suggest that dark matter may even interact weakly with itself, forming vast halos and webs that continue to evolve. It is a quiet presence, imperceptible yet essential, a cosmic scaffolding that has guided the universe from its earliest moments to its current elegance. Even on Earth, dark matter passes through you unnoticed, silently, constantly. Billions of dark matter particles may pass through your body every second, leaving no trace, exerting no force. It is a gentle reminder that we exist within something much larger than our perception can detect. As you drift farther into space in imagination, picture a spiral galaxy spinning silently, surrounded by a halo of invisible matter. The stars trace their orbits, the cosmic web stretches across unimaginable distances, and dark matter holds the whole scene together, calm and enduring. It is the universe's quiet framework, shaping motion, formation, and destiny without fanfare. There is something deeply reassuring about this. Even when the universe feels vast and unknowable, there is hidden order. There is structure, stability, and guidance. Dark matter, silent and invisible, is a steady presence, reminding us that much of the cosmos is still waiting to be discovered, not through flashy explosions, but through careful, patient observation. Tonight, as your thoughts soften and your breathing slows, imagine drifting through the vast web of galaxies, wrapped in the invisible threads of dark matter. It is there everywhere, shaping the universe with gentle gravity. And you, a small part of this cosmic ocean, are held within its quiet embrace, moving along with the gentle, enduring rhythm of the cosmos. As you float deeper into thought, imagine a force that is even more mysterious than dark matter. It does not gather matter, like gravity or invisible halos of dark mass. Instead, it gently nudges the universe outward, encouraging space itself to expand. This is dark energy, the silent, persistent driver of cosmic growth, stretching the cosmos in a calm, unhurried way that has been ongoing for billions of years. When we look at distant galaxies, we notice something remarkable. They are moving away from us, not just due to the original expansion from the Big Bang, but at an accelerating pace. Over the past few billion years, this expansion has quietly sped up, pushed along by dark energy. It is subtle, almost imperceptible on small scales, but across the vast distances between galaxies, its influence becomes profound. Imagine drifting between galaxy clusters, watching their motion in slow motion. Gravity tries to pull them together, but dark energy works in the background, gently stretching the space between them. Over millions of years, clusters drift farther apart. Galaxies that were once near neighbors gradually become distant, faint smudges of light, receding into the quiet darkness. Dark energy is uniform, acting everywhere in space with the same gentle persistence. Unlike gravity, which is stronger around large objects, dark energy is constant across the void. It is the universe's steady breath, expanding space itself, creating more room between galaxies while leaving the stars within galaxies bound together. Even though it is invisible and intangible, dark energy has shaped the universe profoundly. In the early cosmos, matter and radiation dominated, pulling structures together under gravity. But as the universe expanded and matter became more diluted, dark energy gradually took over, accelerating the expansion and sculpting the large-scale cosmic landscape we see today. Imagine floating further into space, beyond the visible galaxies, into the deep voids between cosmic filaments. There is nothing to anchor you. No stars, no planets, only the stretching, expanding fabric of space. And in this silence, dark energy quietly guides the expansion, neither violent nor chaotic, simply persistent. Scientists are still seeking to understand the true nature of dark energy. It might be a property of space itself, an intrinsic energy that exists even in a vacuum. Or it might be a subtle modification of gravity, acting in ways we do not yet fully comprehend. Whatever the explanation, its effect is profound. It ensures that the universe continues to grow endlessly and silently across unimaginable scales. Picture the universe as a vast balloon, gradually inflating over billions of years. Galaxies float like dots on its surface, drifting apart as space stretches. Dark energy is the quiet hand keeping the expansion going, slow and steady, a cosmic rhythm that will continue long after individual stars have faded. Even on human timescales, dark energy feels imperceptible. But on the grand scale of cosmic history, it dominates. Over the next trillions of years, the universe may continue expanding forever, galaxies isolated and faint, drifting apart into quiet solitude. And yet, there is comfort in this gentle push. It is not destructive. It does not create chaos. It simply allows the universe to evolve gracefully, providing space for new stars, planets, and possibilities, while honoring the slow and steady passage of cosmic time. As you drift towards sleep, imagine floating in the dark spaces between galaxies. The stars shimmer softly around you, but beyond, the void stretches outward, guided by invisible hands. This is dark energy, calm, patient, and enduring, a subtle force that shapes the destiny of the universe with quiet grace. Even in the vast silence, there is motion. Even in emptiness, there is influence. The universe expands, galaxies drift apart, and the gentle push of dark energy continues, a soft, infinite exhalation of space itself. As your mind drifts gently across the cosmos, imagine the life of a star unfolding slowly, like a quiet story written over millions or even billions of years. Stars are not static points of light. They are living, breathing furnaces, transforming matter, radiating warmth, and slowly shaping the universe around them. Their life cycles are patient and deliberate, a cosmic rhythm that unfolds with calm inevitability. Stars are born in vast clouds of gas and dust, drifting through galaxies like misty rivers. These clouds, sometimes hundreds of light years across, are nearly invisible except for faint glows of scattered starlight. Within these clouds, gravity works silently, pulling material together in tiny clumps. Over long stretches of time, these clumps grow denser and the gas compresses, heating as it collapses under its own weight. Slowly, a new star ignites at the center, its nuclear furnace coming to life. Imagine watching this birth unfold. The protostar glows softly through the surrounding cloud, casting light on drifting dust and gas. The heat from its core begins to push outward, balancing gravity's pull, stabilizing the star as it enters its main phase, a long period of calm fusion, steadily converting hydrogen into helium. This phase can last millions, billions, or even trillions of years, depending on the star's mass. During this steady life, stars influence their surroundings in subtle ways. Radiation from young stars pushes against nearby gas, shaping future star formation. Stellar winds carry material outward, seeding nearby space with elements that will one day form planets. Stars quietly enrich the cosmos, preparing the ingredients for future generations of celestial bodies. Eventually, every star reaches the end of its life. Small stars, like our Sun, swell gently into red giants, shedding outer layers into soft, glowing clouds called planetary nebulae. The core shrinks, cooling gradually into a white dwarf, a dense ember that fades over billions of years. Even in death, these stars leave a legacy, enriching space with the materials needed to create planets and life. Massive stars follow a more dramatic, though still graceful, path. They live fast and luminous lives, burning through their fuel quickly, until the core can no longer support itself. Gravity wins decisively, and the star collapses. The outer layers explode in a supernova, an immense but brief burst of light and energy that illuminates surrounding space. These explosions scatter heavy elements across the cosmos, providing the building blocks for new stars, planets, and life. Yet, even in these seemingly violent events, there is rhythm and balance. The explosion follows predictable patterns dictated by physics. Energy disperses over time, the shockwave fades, and the remaining core settles into a neutron star or collapses into a black hole. The cosmos continues gently, incorporating the remnants into new structures, continuing its quiet evolution. Some stars exist in pairs or clusters, orbiting one another in intricate patterns. Their interactions can be slow and subtle, gravitational tugs altering orbits over millions of years, occasional transfers of matter, gentle shifts that ripple across time. In this way, stars are never entirely isolated. Their lives are intertwined, contributing to a larger cosmic dance that unfolds without rush or urgency. As you drift further in thought, picture a galaxy filled with stars at every stage of life. Some are young and blue, burning brightly. Others are orange or red, older and slower, approaching the twilight of their existence. Some have exploded in the distant past, their light still reaching across space. Every star, in its own way, adds to the quiet symphony of the cosmos. Even the smallest stars, the dimmest red dwarfs, have lives that can last trillions of years, quietly shining in the dark, almost eternal in their patient consistency. They are reminders that in the universe, longevity and subtlety can be just as remarkable as brilliance and drama. As your thoughts soften and you sink deeper into calm, imagine drifting past clusters of stars, witnessing birth, life, and death unfolding at a pace far beyond human comprehension. There is no hurry. There is no chaos. Only the gentle, measured passage of time, the quiet transformation of matter, and the enduring rhythm of stellar life. The universe, through its stars, teaches patience. It reminds us that even the most luminous entities evolve slowly, contributing quietly to a cosmic balance that stretches across billions of years. In their steady glow and gradual change, stars embody a serene, enduring presence, guiding the universe gently through time. As you continue drifting through the vast calm of space, imagine encountering one of the universe's most mysterious entities, the black hole. Unlike stars that shine or planets that reflect light, black holes are defined by their absence, a region where gravity is so strong that nothing, not even light, can escape. Yet their presence is undeniable, felt through the motion of nearby stars, the bending of light, and the whispers of matter falling into them. Black holes are born from the collapse of massive stars. When the core of a star is too heavy to resist gravity, it compresses into a point of nearly infinite density, a singularity, surrounded by an invisible boundary called the event horizon. Within this boundary, the familiar rules of space and time warp dramatically, creating a realm where conventional understanding gives way to the extraordinary. Imagine floating near, but safely far from, a black hole. Space itself begins to stretch and curve. Light passing nearby bends, creating strange distortions in the view of surrounding stars. Time slows for anything approaching the event horizon, a phenomenon predicted by Einstein's theory of relativity. From your perspective, objects moving toward the black hole appear to slow, frozen in a perpetual, graceful descent. Despite their power, black holes are often silent and patient. Some spin slowly, others rotate at nearly the speed of light. Their magnetic fields, generated by infalling matter, can produce energetic jets that stretch for thousands of light years, glowing faintly against the darkness. Yet even these jets, spectacular as they are, follow patterns and cycles that unfold over millions of years, moving with cosmic patience. Black holes also sculpt their surroundings. Stars orbit them, sometimes in tightly bound clusters. Gas and dust swirl in accretion disks, spiraling inward in slow, luminous spirals before being swallowed. Occasionally, matter is ejected along magnetic field lines, forming delicate, glowing streams that light the otherwise empty space. Every motion is dictated by gravity's unyielding pull, yet it occurs with an eerie calm, a dance performed over vast distances and timescales. Some black holes are supermassive, lying at the centers of galaxies, millions or even billions of times more massive than our sun. They anchor galaxies in place, guiding the motion of stars and influencing the formation of new ones. Despite their immense strength, they remain invisible to direct observation, known only through their effects on the surrounding cosmos. Even in the presence of such extreme objects, the universe feels patient rather than chaotic. Black holes grow slowly, consuming matter over millions of years. Collisions with other black holes create gravitational waves, ripples in the fabric of space-time, that propagate silently across the cosmos. When detected by observatories on Earth, these waves reveal cataclysmic events. Yet even then, they are subtle vibrations traveling through the vast expanse of space. Imagine drifting past a black hole binary, two massive titans orbiting each other in slow circles. Their dance stretches space and time, sending gentle waves outward. The scene is dramatic yet serene, immense gravity choreographing a cosmic ballet. There is no sound, no fury, only motion and influence extending across unimaginable distances. Black holes are also reminders of the limits of human understanding. Inside the event horizon, matter and energy behave in ways we can only describe mathematically. Yet even with this mystery, there is no threat, only an invitation to explore, to observe from a safe distance, and to marvel at the extremes of nature. Even smaller black holes, remnants of individual stars, drift silently through the galaxy. They pass through empty space, invisible, holding secrets of collapsed stars. Perhaps some drift near planets, unseen, yet their presence subtly shapes the surrounding cosmos. As your mind relaxes, imagine the universe filled with these silent titans, each one a patient sculptor of matter and light. Some are isolated, some are at galactic centers, all moving according to the gentle but irresistible force of gravity. They remind us that even the most extreme objects can exist quietly, influencing everything around them without noise or hurry. Tonight, let your thoughts linger on the serene power of black holes. They are not destructive in a dramatic sense. They are enduring, patient, and profoundly calm. In their silent presence, the universe maintains balance, and space continues to unfold with the quiet, endless grace of time. As your thoughts drift gently through the universe, picture a star that has ended its life in a spectacular explosion, yet continues to exist in a form both extreme and serene, a neutron star. Born from the remnants of a massive star supernova, neutron stars are incredibly dense, compact objects where matter has been compressed beyond ordinary imagination. A single teaspoon of neutron star material would weigh billions of tons on Earth, yet these stars, small in size, spin and shine with quiet intensity. Neutron stars are often no larger than a city, yet they contain more mass than our sun. Imagine holding such a star in your mind. A tiny, luminous sphere, radiating in X-rays and gamma rays, its magnetic field billions of times stronger than anything we can create on Earth. These fields guide streams of charged particles, producing steady beams of radiation from the star's magnetic poles. If the star rotates and its beams sweep past Earth, we detect regular pulses, pulsars, like a cosmic lighthouse in the darkness. Picture drifting near one of these stars. Time seems ordinary from your distant vantage point, but up close, the star's gravity is intense. A gentle fall toward it would be fatal, yet from afar, it is mesmerizing. A small, brilliant orb in the vast emptiness, spinning with almost hypnotic regularity. Its energy is constant, persistent, almost meditative. Neutron stars also exist in binary systems, paired with another neutron star or even a normal star. Their slow, gravitational dance can last millions of years, orbiting each other steadily. Sometimes, over unimaginable spans of time, the pair spirals inward, eventually merging in a burst of gravitational waves, silent ripples that move across space, carrying information about the collision far beyond what the eye can see. Some neutron stars rotate at incredible speeds, hundreds of times per second. These millisecond pulsars are cosmic metronomes, precise and unwavering, marking the passage of time in a universe that often seems endless. Even in their extreme environments, there is rhythm, order, and calm. Their spin may slow over billions of years, gradually fading, but their presence leaves a lasting imprint on their surroundings. Beyond their magnetic fields and rotation, neutron stars are laboratories of the extreme. Matter is compressed into forms not found elsewhere, offering insights into physics beyond the everyday. Their interiors may host exotic states of matter, perhaps even free quarks, locked in a dense, silent core. And yet, all this happens quietly, hidden beneath layers of gravity and mystery. Imagine a neutron star surrounded by a faint halo of gas and dust, remnants of the supernova that created it. The halo glows softly in X-rays, shaped by the star's magnetic field, drifting slowly in space. Nothing rushes. Everything unfolds on timescales far beyond human perception, a slow, majestic evolution of matter, energy, and motion. Even in solitude, a neutron star is significant. Its gravitational pull affects nearby stars and gas. It can strip matter from a companion star, forming accretion disks that spiral inward, glowing with gentle heat. Over time, these interactions may produce bursts of radiation, a cosmic heartbeat that continues quietly in the vastness of space. Neutron stars are also reminders of balance. Gravity compresses, but quantum forces resist complete collapse. Rotation steadies, but magnetic fields shape energy flow. Even in extremes, the universe finds equilibrium. Observing these silent beacons encourages a sense of calm, a recognition that even in the harshest conditions, there is order and rhythm. As you drift toward rest, imagine floating past a pulsar, feeling its steady beams of energy sweeping through space like a metronome. Nearby, gas clouds swirl gently, shaped by unseen forces. Light bends subtly under gravity. Time continues its quiet passage. The neutron star, small yet powerful, rotates patiently, a reminder that the universe can be both extreme and serene, violent and gentle, all at once. Tonight, let your thoughts linger on these cosmic remnants, neutron stars spinning silently, marking time with steady pulses, radiating energy into the infinite night. They are calm titans of physics, patient witnesses to the universe's endless story, offering both mystery and comfort as you drift into sleep. As you drift deeper into the calm expanse of the cosmos, imagine galaxies slowly approaching one another, drawn together by gravity in a patient, deliberate motion. Though the term collision might sound violent, on the scale of the universe, it is a gentle transformation, a dance unfolding over millions of years, creating beauty and change without chaos. Picture two spiral galaxies drifting toward each other, their stars orbiting peacefully as the gravitational pull between them begins to influence their paths. Over millions of years, the outer edges of each galaxy stretch into delicate arcs, tidal streams of stars and gas flowing gracefully through the darkness. There is no hurry, only the quiet, inevitable pull that shapes the cosmic scenery. As the galaxies draw closer, their shapes distort into bridges and tails of luminous matter, glowing softly in the vast blackness. Gas clouds compress, and new stars ignite in gentle bursts, forming clusters that slowly shimmer in space. Even what might seem dramatic, supernovae, bursts of radiation, streams of matter, occurs over such long spans of time that the events feel like calm brushstrokes rather than explosions. Imagine observing from a safe distance as their cores spiral together. Stars mostly pass by one another harmlessly, separated by vast distances. The galaxies merge gradually, forming a new, larger galaxy. Spiral arms twist into new patterns, central bulges form, and the galaxy's histories become intertwined. It is a quiet reminder that even the most dynamic cosmic events can unfold with grace. Collisions are not limited to galaxies. Stars themselves can interact gently within clusters. Occasionally, a binary system captures a wandering star, adjusting orbits over time. Comets and asteroids may drift past one another, nudged subtly by gravity. Even black holes can meet and merge, sending silent ripples through space-time, gravitational waves, which travel across the universe at the speed of light, carrying information about these slow, majestic encounters. Picture a cluster of galaxies in a dense region of space. Each galaxy moves with purpose, influenced by the gravity of its neighbors. Over billions of years, some merge, some drift apart, yet all follow a natural rhythm, a patient choreography guided by invisible forces. The motions are subtle, continuous, and inevitable, creating order without hurry. Cosmic collisions also create fertile ground for new structures. Shockwaves from merging galaxies can compress gas, triggering waves of star formation. Nebulae glow brighter as new stars emerge. Planetary systems may form quietly in the aftermath, building the ingredients for worlds that might one day harbor life. Even destruction leads to creation, unfolding slowly and beautifully across space and time. Imagine drifting through a quiet galactic bridge, stars scattered like glittering dust, gas clouds stretching gracefully, the soft glow of newborn stars illuminating the darkness. There is no chaos, only movement, shaping matter and energy into new forms, a gentle reminder that the universe evolves continuously. Even our own Milky Way is part of this cosmic rhythm. In a few billion years, it will meet the Andromeda Galaxy. The process will be slow and majestic, a ballet of stars and gas forming a new galaxy over millions of years. The vast distances between stars ensure that, despite the seeming violence, nothing collides in a dramatic way on a human scale. The universe is full of such slow transformations, from the merging of galaxies to the gentle spiral of star clusters. It is a place where change occurs gracefully, guided by gravity and cosmic forces, unfolding on timescales so vast that the mind can only imagine them. As you drift toward sleep, envision these cosmic dances playing out silently around you. Galaxies twist and merge, stars ignite and fade, black holes spiral together, and gravitational waves ripple softly through space. The universe transforms continuously, yet with patience, elegance, and calm, a serene symphony of motion across the infinite night. As your thoughts drift softly through the universe, imagine a realm filled with tiny, almost invisible particles, cosmic dust. These minute grains, smaller than a speck of sand, float silently through space, carried by gentle stellar winds and the quiet pull of gravity. Though small and subtle, they play a profound role in shaping the cosmos, guiding the birth of stars, planets, and even the building blocks of life itself. Cosmic dust is born in the final breaths of dying stars. When stars like our sun swell into red giants, they shed their outer layers, scattering microscopic particles into space. Supernovae also contribute, blasting enriched material across galaxies in a slow, radiant drift. Each grain carries the history of its star, the memory of processes that took place billions of years ago. Picture drifting through a nebula where these grains float in clouds of gas, illuminated faintly by the light of nearby stars. The dust absorbs starlight, scattering and reflecting it, giving the nebula a soft, ethereal glow. Within these quiet clouds, gravity and dust collaborate. The particles slowly clump together, forming dense pockets where new stars will ignite, beginning the cycle anew. Cosmic dust is also essential in forming planets. Around young stars, dust gathers in rotating disks, colliding gently over millions of years. Small grains stick together, gradually forming larger clumps, pebbles, and eventually planetesimals. Over time, these accumulate into planets, moons, and asteroids. Without dust, the cosmos would lack the intricate structures that make worlds like Earth possible. Even light traveling across the galaxy is shaped by dust. When starlight passes through dusty regions, it is subtly reddened, scattering softly like sunlight through morning fog. This gentle effect allows astronomers to trace the presence and distribution of dust, revealing hidden structures in the galaxy that would otherwise remain invisible. Imagine floating near a protoplanetary disk around a newborn star. Dust swirls gracefully, glowing softly in infrared light. Tiny collisions build larger aggregates, forming the seeds of future worlds. This process is calm, patient, and slow. A quiet construction project spanning millions of years, invisible to the human eye, yet essential to the universe's architecture. Cosmic dust also carries the elements necessary for life. Carbon, oxygen, nitrogen, and other heavy elements created in stars are scattered into space, joining dust grains and drifting toward new star systems. These particles become part of planets, comets, and asteroids, eventually delivering the raw ingredients for chemistry that may lead to life. Even in our own solar system, dust plays a subtle role. The zodiacal light, a faint glow visible in dark skies just after sunset or before sunrise, comes from sunlight reflecting off tiny dust particles between planets. Meteor showers occur when Earth passes through dense streams of cosmic debris as the grains burn gently in our atmosphere, producing fleeting sparks of light. Cosmic dust reminds us of the universe's patience. It does not rush. Every planet, every star, every molecule of life begins with these tiny grains, moving slowly, quietly, guided by gravity and time. The processes unfold across millions of years, and yet they produce the intricate, beautiful structures we see across space today. As you drift further into calm, imagine floating through a galaxy filled with these delicate grains. Nebulae glow softly, star formation hums quietly, and the building blocks of worlds drift patiently in space. Even the smallest particles participate in the grand symphony of creation, showing that in the universe, every detail, no matter how minute, contributes to the whole. Tonight, let your thoughts linger on these silent architects of the cosmos. Cosmic dust is gentle, persistent, and essential, forming stars, planets, and the foundations of life itself. It is a quiet reminder that even the tiniest particles can shape the universe in profound and enduring ways, moving with grace and patience through the infinite night. As your mind drifts through the quiet expanses of space, imagine worlds far beyond our solar system, exoplanets, orbiting stars in distant galaxies. These planets, unseen by the naked eye, are as diverse and wondrous as imagination allows. Some are massive gas giants, swirling with storms, while others are rocky, serene, and possibly capable of harboring life. Each exists in silent orbit, moving gracefully through the darkness, illuminated only by the distant light of its parent star. Exoplanets come in countless varieties. Some hug their stars closely, heated to extreme temperatures, while others drift far away in frigid isolation. Some orbit multiple stars, their skies filled with twin or even triple suns. The universe seems to delight in variety, arranging each system in quiet harmony, where planets trace paths dictated by the gentle pull of gravity. Picture observing a distant planetary system from afar. A massive gas giant casts its shadow over swirling clouds of ammonia and methane, while smaller rocky planets glide silently in the same system. Each world follows its orbit with unhurried precision, tracing patterns that have persisted for millions of years. There is no chaos here, only motion that is calm, steady, and enduring. Astronomers have discovered thousands of these exoplanets using subtle methods. The tiny dimming of starlight as a planet passes in front of its star, the faint wobble of a star caused by a planet's gravitational tug, or the faint infrared glow of a distant world. Each detection is a quiet revelation, a hint of life unfolding far beyond our immediate gaze. Some exoplanets may be entirely unlike anything in our own solar system. There are super-Earths, larger than our planet but smaller than Neptune, with dense atmospheres that could harbor exotic weather. There are hot Jupiters, gas giants orbiting so close to their stars that their skies blaze with perpetual heat. And there may be ocean worlds, shrouded in icy shells, hiding deep, liquid oceans beneath, whispering possibilities of life beneath frozen surfaces. Even in these distant systems, time flows patiently. Planets orbit their stars with calm regularity. Seasons shift slowly. Atmospheres circulate gently. Storms rage over decades or centuries, yet all occurs in harmony with cosmic law. From afar, these worlds seem almost meditative, moving through space with grace and consistency. Imagine a night sky on an exoplanet orbiting a red dwarf. The sun is small and dim, casting a warm, steady glow. Two moons might drift overhead, slowly tracing arcs across the sky. Perhaps nearby gas giants loom in the distance, silent titans overseeing the system. Everything feels slow, rhythmic, and calm, a universe unfolding gently, moment by moment. Some exoplanets are in the so-called habitable zone, where liquid water could exist. Though we cannot yet know whether life flourishes there, the thought itself inspires quiet wonder. Each planet is a possibility, a gentle reminder that the universe holds mysteries far beyond our reach, patiently waiting to be discovered. Even rogue planets, drifting alone through interstellar space without a parent star, maintain their silent journey. Their paths are determined by gravity, their presence almost ghostly as they glide through the darkness, unseen yet real, a reminder that motion and existence continue even in isolation. As you drift toward deeper calm, imagine gliding through a vast field of exoplanets, each one unique, each orbiting with steady grace. Some shimmer faintly with reflected starlight, others glow softly with residual heat. Together, they form a gentle, diverse chorus of worlds, each moving according to the timeless laws of the cosmos. The universe is full of these silent planets, drifting calmly, orbiting patiently, and holding secrets we can only dream of. They are reminders that even in vast darkness, life, motion, and potential exist, moving quietly and gracefully, inviting curiosity, wonder, and serenity. Tonight, let your thoughts linger on these distant worlds, each one a silent guardian of its star, each one a gentle participant in the cosmic rhythm. Exoplanets teach patience, harmony, and the beauty of quiet existence, a serene promise of the universe's endless variety and gentle majesty. As your mind drifts into the final stretch of this cosmic journey, imagine floating beyond galaxies, beyond clusters, into the vast, quiet expanse of intergalactic space. Here, the universe stretches endlessly in every direction, a dark ocean dotted with distant stars and galaxies, moving with a slow, deliberate grace that has continued for billions of years. There is no rush, no urgency, only the calm, unhurried flow of space and time. In this infinite night, the light of distant galaxies reaches you after millions or billions of years, each photon a messenger from the past. Some stars have long since burned out, yet their light continues its gentle journey across the cosmos, reminding us that time and space are patient and persistent. Even as individual stars flicker and fade, the universe carries on, vast and enduring. Imagine the void between galaxies. It is not empty, but filled with diffuse gas, invisible dark matter, and the faint hum of cosmic radiation. Even here, there is movement, subtle and gentle, galaxies drifting slowly apart under the push of dark energy, clusters interacting quietly, and cosmic dust floating in silent ballet. Space itself expands, stretching without haste, creating room for new stars, planets, and possibilities to emerge. Consider the cosmic horizon, the limit of what we can observe. Beyond it lies more universe than we could ever see, continuing indefinitely. Every point of light, every particle, every whisper of radiation is part of a tapestry that extends far beyond imagination. The universe is immense, yet coherent, structured yet patient, moving forward without hurry, allowing creation and transformation to unfold gracefully over billions of years. Even time itself is a gentle companion. Past, present, and future are connected through cause and effect, through light traveling across the void, through the slow dance of galaxies. There is no abrupt ending, only continuity, a calm flow that carries matter, energy, and light across unimaginable distances. Imagine drifting alongside a distant galaxy, observing stars spinning quietly around a central black hole. Dust clouds drift lazily through spiral arms, igniting the birth of new stars in soft bursts of light. Nearby, a neutron star pulses steadily, marking time with patient precision. Everything moves according to cosmic rhythm, slow, measured, eternal. As you float further, picture the universe as a vast, living canvas. Dark matter threads weave galaxies together, invisible yet omnipresent. Dark energy stretches space, creating gentle expansion. Stars live and die in graceful cycles. Planets orbit quietly, some alone, some in systems of delicate complexity. Even the smallest particles, cosmic dust, photons, neutrinos, drift with subtle purpose, participating in the grand, calm unfolding of existence. The universe teaches serenity. It reminds us that time is vast, that even dramatic events unfold slowly, and that change is natural, continuous, and harmonious. Supernovae, black holes, colliding galaxies, all occur with patience, guided by unyielding laws, yet without chaos. The cosmos is a gentle, endless process, revealing order and beauty across unimaginable scales. Tonight, as you let your thoughts settle into quiet reflection, imagine floating in the infinite dark, surrounded by stars and galaxies, carried gently by cosmic forces. Feel the slow expansion of space, the rhythm of stellar life, the silent pulse of neutron stars, and the soft whispers of radiation and dust. The universe moves with patience, allowing creation, evolution, and transformation to unfold naturally, gracefully, eternally. Let this vision of the endless night fill you with calm. The cosmos is vast, mysterious, and gentle. It moves without hurry, transforms without chaos, and continues quietly, endlessly, inviting you to rest in its serene embrace. As you drift to sleep, know that you are part of this cosmic story, a small, luminous presence in an infinite, patient, and ever-evolving universe.